Hello everyone. Saffron is my latest side project, which is a collection of compositor nodes for Blender, focusing on color grading, photo editing, and color management. Here's some before and afters to give you an idea. The nodes are split into several categories, so let's go through them one by one. Saffron Grade is all about color grading. You can adjust the general tone of the image, play with the colors, or grade shadows, midtones, and highlights separately. Saffron Grade is made with custom algorithms and uses OKLab as its processing space, a perceptually uniform color space which was developed by this person. Color Zone lets you isolate a certain hue range, like only the blues to select the sky or greens for grass, and then you can adjust the tone of that part. With Saffron Effects, you can adjust the details, add vignetting, film halation, or film grain. These nodes let you turn your image into a grayscale version using different methods. Masking is a technique used to vary the strength of an effect at different positions on the image. Here I'm using a radial gradient mask to cover the subject's face and only brighten that part. You've also got linear gradient mask and masks that select a certain color range. You can combine different masks by adding, subtracting, or intersecting them. This section provides more niche features for the nerds among us. Play with them if you're interested. Color spaces give meaning to triplets of numbers we use to describe light spectra. For example, 111 means nothing on its own, but 111 in linear BT709 ID65 refers to the white point of daylight 6500 Kelvin. Don't worry if this is completely new to you, as I'll try to explain just what you need to know. Saffron supports common linear spaces, OKLab, and some ACES color spaces. Finally, we have view and display transforms, which we'll discuss in more detail in a bit because we need to talk about. There are three main types of color spaces you need to know about: linear spaces, encoding spaces, and grading spaces. In a linear color space, the numbers are proportional to physical quantities like the power of light in a certain range of wavelengths. 3D rendering, blurring, bloom, blending, and most other effects should almost always be performed in a linear color space like linear BT 2020. However, when we send RGB data to a display device using only 8 to 12 bits per color channel, we want to make the most use of that data. For example, since our eyes are more sensitive to changes in dark areas than in bright ones, an encoding space might use a logarithmic or power distribution to spend more combinations of bits on darker values. Encoding spaces are used in displays and cameras, and a common example is sRGB. Apart from these, there are also certain color spaces designed for color grading, like ACES CC or OKLab. These may use custom transformations to make color adjustments more intuitive. In digital content creation software like Blender, color management is basically about one thing. Pick a color space, usually a linear one, as your working space and process your images in that color space. When you load external images or videos, convert them from their own color spaces to your working space. And when displaying the result, convert it to your display's encoding space. And when exporting, convert to whatever the file format expects. In order to use Saffron, we need to disable Blender's color management system because Saffron has its own. To do this, go to Render Properties, Color Management, and set the View Transform to Raw or None. Also, when loading external images with image nodes, set the color space to non-color or generic data. If you already have image nodes, change them too. Now that we've disabled Blender's color management, we need to do it ourselves. Here's an example to help you build an intuition. Say our working space is linear BT709 and we load an image file named plants.jpg. When working with a PNG or JPEG, there's almost a 100% chance it's in the sRGB color space. On the other hand, linear image formats like OpenEXR typically use a linear color space. If you've rendered a 3D scene, the resulting image can be accessed through a Render Layers node. The output of this node uses Blender's own working space, which is linear BT709 by default, but it might change in future versions of Blender. Anyway, the next step is to set the color space to non-color and convert the image from its color space sRGB to our working space BT709 using Saffron. After that, we need to convert to our display's color space, like sRGB or display P3. If you don't know yours, look it up based on your display model. In this example, we assume an sRGB display device and therefore use the linear BT709 ID65 to sRGB conversion node. Finally, any processing happens before the display transform while we're still in the working space. Right before the display transform, we can optionally add a view transform or a so-called tone mapper to make sure our colors are not exceeding 100% brightness level, because that introduces clipping in bright areas. A good option is flim, my Filmic Color Transform. I have a whole video on flim and color spaces in general, so make sure to watch it after this one if you're interested. Now, view transforms don't modify the color space. They just make your colors reach 100% in a smoother and more visually pleasing way instead of applying a harsh cutoff. The output is still in the working space, which is why we still need that display transform at the end. If we made a node to convert between every combination of color spaces, we would have hundreds of nodes. To work around this, we choose a reference color space and implement conversions to and from that space. With this system, if we want to convert from a color space A to a color space B, we simply convert from A to the reference and then from the reference to B. Here's an example where we convert from linear BT709 to OKLab using this method. Note that display transforms are an exception to this. Pay attention to the input sockets on the nodes. Some inputs are named in RGB. This means they expect the input to be in a linear RGB color space like linear DCI P3 or BT709. An InRef socket means the input must be in the reference color space, and so forth. The same is true for output sockets. For example, out OKLab means the output is in OKLab. But Bean, you ask, what if I need a conversion for a color space that's not supported by Saffron? Well, don't worry, you can use Blender's Convert Color Space node the same way you use Saffron's conversion nodes. Here I'm applying the AGX View and Display Transform using this node. When exporting, set Color Management to Override and View to Raw or None. Obviously, exposure and gamma need to be at their default values. If you're exporting to a linear format like OpenEXR, set color space to non-color. Also, make sure you've disabled your display transform so that the image stores linear data. In general, the exported file will use the color space from your last conversion node. If it was a conversion to sRGB, the exported file will be in sRGB and so on. If you're exporting for the web and want the highest compatibility, use linear BT709 as your working space and sRGB as your display transform. Of course, if your display uses something else, like display P3, add a conversion from sRGB to display P3 at the very end so that the image looks correct on your display when you're editing, but make sure to disable it when exporting. To use Saffron in your own Blender project, download Saffron's blend file. In your own blend file, go to File, Append. Find Saffron and double-click on it. Double-click on Scene, then Saffron Compositor nodes. In the top right corner, change the current scene to Saffron compositor nodes. Go to the Compositing tab and select all of Saffron's nodes, then hit Ctrl-C to copy them. Change back the scene. Check Use Nodes if you haven't already, and hit Ctrl-V to paste the nodes. Set the view transform to raw to disable Blender's color management. And finally, add in a display transform matching your display device. You can also add a view transform like flim to get a more natural look. At this point, you can do all your grading and processing in the working space before the view and display transforms. Try all the different nodes Saffron provides and make some pretty art. You can get access to all of this for only it's free. Saffron is free and open source. This means that everyone can contribute by adding more features or improving the existing ones. If you want to do just that, feel free to make a pull request. If you feel the project is deserving, you can give me a tip at ko-fi.com. Support is greatly appreciated. Thanks for watching.